In this video, we're going to see how to handle more complicated exponential and logarithmic equations. Mainly, we're going to be using properties of logarithms in order to help us solve them. So for this first one here, we have log base 3 2x plus 1 minus log base 3x minus 2 equals 2. We learned how to convert from log to exponents, and that was a huge thing for helping us solve equations. But the problem is we have two different logs here. That method only works if you have a single logarithm. If you have more than that, it does not work. So what we need to do is we need to use properties of logarithm in order to combine these together, and then we'll be able to solve it. So when you're subtracting logs, we know that you divide the insides. And then once we've got it down to a single log, we can do our trick to convert it to exponents. We have 3 squared is 2x plus 1 over x minus 2. We then go ahead and clear the denominators here. This would give me a 9x minus 18 equals 2x plus 1. I can move the 2x over and the 18 over and divide, and we get 19/7, and that is our answer. I want to remind you that you should double check plugging this in. Make sure that it's not going to make anything inside the logarithm negative, otherwise it would be not a valid answer. But for these ones, a lot of times you will have at least one answer that works here. For the next one, we're adding two logs, so we know the rule says you multiply the insides. And then once we've got it down to a single log, once again, we go ahead and convert here. We'd have 2 squared equals the inside, x plus 2, x minus 1. We go ahead and multiply things out here. Plus 2x minus x is plus x minus 2. Move the 4 over here. Go ahead and factor the result, x plus 3, x minus 2. We get two answers there, negative 3 and positive 2. However, if you plug in negative 3, if you plug in negative 3 in the original problem, you would have a negative inside a logarithm, which is not allowed. So negative 3 is not a valid solution, but x equals 2 is. This next one looks more complicated because it has 3 logs there. However, it's actually going to be a little bit easier. We go ahead and combine the logs on the left-hand side like we've done before. X times x minus 1. And then instead of having to do our log trick of moving things around, we can just realize that if you have log 5 of something equals log 5 of something else, the only way that's possible is if the insides of the logs are the same. So you just basically remove the logs from both sides. Same as really taking 5 to the power of both sides. But then we go ahead and multiply things out, move the 6 over. This one factors slightly differently than the last one. We get 3 and negative 2. This time it's the negative 2 that won't work, but the 3 does. And this gives us our answer here. So the fact that there's a log on the right-hand side, it makes it look worse, but it's actually maybe slightly less work to solve the problem. I will say all of these things here, they work out this way because everything in the same problem is the same base of the log. If this had been like a log base 5 plus a log base 7 equals a log base 9, it's not going to work out so easy. It is possible to solve those types of problems using the change of base formula, but it's not something we usually see in a class like this. Just keep that in mind that for us here, we're probably going to always have the same base logarithm in a given problem. Now this last one here is a more complicated exponential equation. Now we've seen ones before where you had base to x involving equals some number. You convert to a logarithm. But the problem here is we don't know if we should use log base 3 or log base 5 for our logarithm, because we have both in this problem. So when you have a mixture like this, you can actually just choose to use any log you want. The most commonly used one is ln. So ln is just used in science so often, so we just get used to it. And what we do is we're just going to apply ln function to both sides of the equation. So we just apply ln on both sides. Then we use the property of logarithms that says we can take exponents and put them down in front. And this would be x plus 1 times ln 3 equals 2x times ln 5. Then I'll distribute the ln 3 on the left. So ln 3x plus ln 3 is 2x ln 5. What I'm going to do now is I'm going to subtract the ln 3x to the other side so that I have all the x's on one side. And then this is going to look a little weird, but I'm going to factor the x out because they both have an x. And this other part here, it looks weird, but it's a number. It's 2 ln 5 minus ln 3. And if you really want to, you could put in a calculator to get a decimal, but this is the exact answer here. And then we divide, and we get ln 3 over 2 ln 5 minus ln 3. And this is how we get our answer for x. So when both sides have different bases, and they all have exponents with x involved, choose whatever log you want and apply it to both sides. ln is the kind of default. It's used in a lot of places, but you don't have to use ln. Then you use your properties of logarithms to bring exponents in front. Then you multiply things out, gather like terms together, and that will give you the value of x.